Okay, so now let's go ahead and get started. Like I said, my name is Brynsvold. I'm an Android developer working for Atlassian. I just started there a couple months ago, and prior to that, I had worked for a mobile dev agency in Austin, Texas, and spent a couple years doing mobile app consulting. Got my Twitter handle up here if you need to get a hold of me afterwards. At any point during the presentation, if you have a question or if something isn't clear, feel free to let me know and interrupt and we can talk about it. Today, talking about being a better battery citizen. So frequently when developing our apps, we have tunnel vision. We're very laser focused on just our app and nothing else matters. We just think about our app, we think about our network requests, our push notifications, our background processes, our disk storage, and that's all we take into account whenever we build our apps. But in reality, people have other apps installed on your phone, and all of those apps have their own network requests and their own push notifications and everything else. So what we're building and what we're developing, we need to realize that we're not the only thing. We're not the biggest fish in the pond. Unless anyone in here works for Facebook, you're probably not the #1 app usage on someone's phone. So we need to be careful about what it is that we're doing and the battery impact that may have, for example. So does this picture stress anybody else out? The low battery mode on Lollipop and later is really nice. Turns off animations. Basically, gets that extra couple minutes out of your battery. But every time I see that orange come on, just this kind of like pit forms in my stomach of like, oh gosh, I'm gonna run out of battery. Just have a bad association with that. There was a survey done a couple years ago where they asked people if they would feel stressed if their phone's battery died and they didn't have access to a charger, and 92% of respondents said they would feel stressed out. I know I would feel stressed out if my battery died. And on top of that, even 25% of respondents said that they would feel panicked if their phone died and they didn't have the ability to charge it back up. So this is really important to people. But what can end users actually do about the situation? So the first thing that they could do is check out the battery information screen that Android gives you. This has changed a lot throughout the years. This is the Nougat version, and it gives you some information. The graph there is nice, so you can kind of get an idea of how much battery you use over a period of time. You can kind of line up like, okay, if it's steeper here, this is when I was actually using the phone. But then if you look at those categories, what does that really mean? The first thing is screen. Okay, I use 17% of my battery on screen, so what can I do about that? Should I just not use the screen as much? Should I turn down the screen brightness? I guess that could probably help. But then you look further, there's Android OS, there's Android system. I'm an Android developer. I don't even like what makes something count as Android OS. What makes something count as Android system? Is that an app that's using some sort of like platform service? Is that, if I'm using Firebase, does the Firebase stuff count as Google Play services or Android system, or how's that all packaged together? And then the only app I even see on this list is Falcon Pro, which is a Twitter client. So since that is using the most battery, does that mean that I should look for a different Twitter client? I don't think so. I think probably just means I should spend less time on Twitter, because that's probably what I was doing the most on this day. Not only is it good for battery life, but it's probably good for your life as well, just spending less time on social media. So looking at this information, it's kind of hard to tell how to make small changes to actually improve your battery life. So maybe there's an app in the Play Store that can help. So if you search on the Play Store for battery, you just get tons of results, things that can save your battery, things that can calibrate your battery or repair your battery or optimize your battery. And I was kind of actually surprised that most of these seem to have 4+ star ratings, but I can't imagine that they help much or do much of anything. It might just be kind of a placebo effect. Really, most of these apps, what they do is they just kill background processes, which, as we know, can in some cases actually hurt your battery because you're shutting down something that then is going to start up again, and that startup cost actually is more expensive than leaving it on in the background. So end users, there's not really much they can do to save their own battery life, so us as developers, we have the responsibility to manage our own app's battery. That responsibility is kind of a thankless job, though. It's one of those improvements where if it's going well, no one's going to leave your app a 5-star review that says, man, this did a really good job conserving my battery life. I really liked using this app because it didn't use my battery life. You will get 1-star reviews, on the other hand, if it drains too much battery. I went and looked, these are a couple of reviews from Snapchat. So there are a couple of reviews where, hey, you're using too much of my battery, this sucks. And the good reviews were all just about the product itself. So if you get out of the way, if there aren't any problems, then it lets your features and it lets what your app is designed for to shine through. So obviously, battery life is important. Probably didn't need to spend 10 minutes telling you that it's important, but it just kind of reinforces it. So let's talk about some of the tools that we can use to inspect battery performance. The first thing that we talk about a little bit is called Trepin Profiler. So different things like CPU usage, GPU, network monitoring, mobile data, but the thing that we're concerned about here is battery monitoring. Battery monitoring power drain is actually something that is relatively difficult to do without a hook into the processor itself. So since this is from Qualcomm, the battery monitoring only works on Qualcomm processors, so only on Snapdragon processors. On their site, they have a support forum page that lists out officially supported phones and devices, but for the most part, things like the Nexus phones, LG phones, Motorola phones, HTC, those are all supported. There's also a list of unsupported devices, and most of the ones on there are Samsung phones. So if you have a supported phone, then you could use Trepin Profiler to get some interesting battery graphs that look like this. So this is the output of a battery profiling run with Trepin Profiler. It's graphing power draw in milliwatts over the time of the test. So this is about a 5-minute test, and you can see at the beginning the power draw was slightly lower, and then it kind of leveled out. I mean, it's all over the place, but in things like this, you're mostly looking for trends. So I used this app a couple years ago when I was doing a project for a company that was broadcasting, or a video broadcasting company. They had a video streaming app that used an off-the-shelf video player SDK, but they wanted to do some evaluations in comparison to some other video player SDKs to see if those performed better. We're supposed to look at a couple different things like ease of integration, how well you could insert ads into streams, whether the video playback worked well on live streams or on-demand streams. And one of the things that we were tasked to look at was battery life. We wanted to test the app under different network conditions as well. And we also didn't want to just run one test and have that be the final result. So for every test, significant. But what we did was ran live tests and video on demand tests on different network configurations, so 3G, LTE, Wi-Fi. And then at the end of it, I only still had the data around for one of the video players, so this is one video player for 3 different network configurations. But then we compared that over the other 2 players, and there was actually a difference in the video players. The The main thing that it correlated to, though, was like the network quality. So if you were pulling down a higher quality video stream, then you were going to be using more battery because you're using more network traffic, which kind of makes sense there. Another thing that's kind of interesting on this graph is you do see that little bump at the beginning. And so this video was a 5-minute video, but at the beginning of it, the screen was dark and it was doing some buffering, and so that's why there was a little less impact or less power drain at the beginning, just because the screen was darker. So it's kind of interesting to see that represented in graph form. So that is Treppin. That gets you really raw battery information. But there's another tool called Battery Historian. So Battery Historian works with devices running Lollipop and later. Whenever I did that last project, it was late 2014, so Lollipop had just come out. We wanted to do some comparisons on Lollipop, but we also wanted to run the tests on some older devices, so we weren't able to use Battery Historian for that. If I were to do the tests again, I would definitely use Battery Historian instead. So for any sort of battery testing, that's probably what I'd recommend today, as long as you can run it on Lollipop or later. So let's take a look at the output and see what you can get from it. So this is a ton of data that you get from running Battery Historian. I should say Battery Historian itself is it's basically a web app that takes data from your phone and renders it into this nice graph. So Battery Historian refers to the web app itself. So a lot of information here. The big black line in the middle here is your battery level over time. So this is a battery report for an entire day for my phone. So starting at 8 a.m. or something, going until 5 p.m. whenever I ran the report. So because it's lined up by time, you can see here in the middle of the day when I wasn't using the phone as much, it was decreasing less, and then periodically throughout the day as you're using it, the battery drain increases. Because it's all lined up by time, it's easy to see what caused this sort of power drain. I'm not sure if everyone can read all these things over here, but the top item is whether the CPU is running or not. Some other things on the fourth line here, these red bars are when the screen was on. So I wasn't using the app this whole time. There were a couple times when I turned the screen on maybe. But then you can see there's a couple of times when I was using it here and it drained a lot. I was using the app here and it drained a lot. Gives you a lot of information. All of the different colors mean something too. And you can hover over these little info icons over here on the left to get some more information about that. Let me go ahead and pull up this report just so I can interact with it some. Okay, so this is that same report here. Let's see. So right here we have Wi-Fi signal strength. There's a couple different colors here for yellow and red and green. And so if we wanted to know what that was, you can hover over this little information and it'll tell you logically, I guess, that red is for poor, orange moderate, yellow is good, and green is great. So you can see here at this point, this was on Tuesday, so this was, I was in a class and my phone was in my pocket and the Wi-Fi wasn't super great. So because it was struggling to connect to Wi-Fi, the power was dropping maybe a little faster than it would have. So if you want to get some information about your own app, a couple of these will tell you, will give you a little more information. Let me see if I can rerun this or not. I feel like the tool is a little finicky. So that sometimes there were some bars that were there and there were some bars that were missing. Maybe that wasn't a good idea. Yeah, okay. So to use this tool, you just come in here and select the file. We'll talk about how to get the files in just a second. Then it processes the file and renders the graph. There we go. So this is what I was looking for, this top app line. Now there's a couple things here where it will tell you what the app, the most used app during that time period was. So here, you can see there was a game I was playing in the middle of the day for 15 minutes. Some of the other ones, Snapchat, whatever. So this is good for just kind of getting an overall picture for your entire phone. But if you want to narrow down the focus to just one app, if you scroll down here, there's a ton of more information. There's stats for the entire system. There's stats for the history over a certain amount of time. But then you can filter down to just app level stats. So inside of this box here is a list of all of the apps that I have installed on my phone. Oops. And then if you know the package name, you can type it in. So I'm going to type in HipChat, if I can type. And I can get information about the power usage specifically for HipChat during this battery report. I didn't use it very often. It only used 0.01%. It only had 1 second of CPU time. But then you can expand this information. You can get information about services that your app is running, information about the process it's running in. There's also a section here for wake locks, so if your app has wake locks. HipChat doesn't, or at least it wasn't using any here. So a lot of this information, whenever you're viewing it just as one report, a lot of the information is kind of like a sanity check. If you're developing your app, you know that you have a service. It shouldn't be a surprise to you that a service pops up in that list. What could be a surprise is if that service is running a lot longer than you expect, or if it starts up 30 times in 30 minutes and you are only expecting it to start up once. So when you're looking through this report, you're kind of looking for those stats that might jump out at you, the stats that would not be expected, I guess. Okay, so how can we run this ourselves? Like I said, Google built it using Go, and if you want to, you can download the source from GitHub here and build it all yourself. If you don't want to do that, then you can use Docker to run Battery Historian yourself, and that gets an image that already has everything set up for you. You don't have to build anything from scratch. If you haven't used Docker before, it's basically just virtualization software that lets you download pre-configured images to your machine, and it lets them run in containers. It's really handy to use. I had this slide up at the beginning of the class, so some people have already done this. I'm not sure how, for the people that did this, how long did it take to pull everything down? Did it take a while? Is it still going? 2 minutes? Okay. I was a little worried that maybe everyone doing it at once could stress out the network. So if you want to, you can do this now. If you don't want to, there is another option. But these instructions are just pulled from the README on the Battery Historian GitHub page, so you don't necessarily have to copy the whole thing down now, but you can if you want. So I was going to tell you not to do this, which is why there's a big stop sign, but that's okay. So If you don't want to set up yourself, we can take advantage of a server that someone else set up. If you go to this shady-looking URL, then there's an instance of Battery Historian running there. You know, do that at your own risk. So the bug reports that we are collecting here, basically what it does is it runs dump sys, it runs dump state, and it runs logcat for the entire period of however long your phone has been fully charged. So if it was fully charged in the morning until now, then it would be the last hour or two, or it could be all day. So we, as good developers, obviously do not log important, sensitive things to production. But some other apps that you may have on your phone could be logging things like email addresses or other information that you might not want public. So if you're running Battery Historian on your own computer, you know that there is no chance that you've written anything that could do anything with that information. According to the Reddit post that I got this from the author, he says he's very positive that he is not collecting any of that information, but it's also the internet, so take that with a grain of salt. I'm absolving myself from any responsibility if you get your identity stolen by using this website, but whatever. So the command that you run here, if you're on Marshmallow or earlier, and really that should be Marshmallow or Lollipop because it doesn't work pre-Lollipop, on the command line, once you have your phone plugged in, and as long as you have debugging enabled, then you can run ADB bug report. That command will output the entirety of the bug report to your terminal. So then you can just, instead of just running that, you can pipe that out to a text file. That text file ends up being like 13 megs of text, so there's a lot of information there. You probably don't want to just dump it out on your terminal. I did that the first time, and it's like, okay, I'm not going to try and copy this, so I had to run it again. If you're on NuGet or later, you have another option where you can specify the name of a zip file, and then that file is smaller. It's only 4 or 5 megs, but it has all the same sort of information in it. Okay, so a couple of tips about using Battery Historian. Like I said, whenever you run that command, it gets you the battery stats from the time when your phone was fully charged until now. But if you're trying to run tests just against your app, maybe you don't want the full day's worth of information. What you can do is run another ADB command that will reset the battery stats. So let's say if you're running a test, I'm going to reset battery stats, I'm going to unplug my phone, I'm going to run my app for 5 minutes, then I'm going to plug it back in and do that, the command on the last slide to pull down the battery stats and look at it in Battery Historian. So then you're not having to filter through an entire day's worth of battery information. You're just focusing on the things that are relevant to your app. The second thing there I just mentioned, which is unplug your phone while testing. If you have your phone plugged in, then it's drawing power, and that can affect the statistics somewhat if you are charging at the same time as draining power. So you want to have as close to a real-world experience as possible, so you want to unplug your phone there.
But we had to connect to the computer.
Right, yeah, so connect it, run ADB, unplug it, and then run your tests, then plug it back in. So you do have to plug it back in, which is why on this previous slide, basically on all of your reports, you're going to get this little bit at the end that says you were charging it because you have it plugged into your computer to actually do the battery stats call. The last thing that you can do, this is pretty helpful for debugging your app personally, is if you run multiple tests to compare 2 different reports. So this was the screen that we used to upload a file. You can only upload 1 file, but there's this button down here to switch to bug report. I assume that says comparison. And when you click that, then the other buttons go away and you get 2 file entry sections. So I tried this. Basically, for your testing, what you would want to do is run a bug report, look at the battery information. If you see something that looks strange, if you see that your services are going crazy, if you see your wake clocks are going crazy, if you identify something that's wrong, then you can fix that, and then you can run a second test doing the exact same things, and then compare those two battery stats reports and make sure that what you fixed, number one, fixed the issue, and number two, didn't actually make it worse. So what I did was I ran our Confluence mobile app. Confluence is just our wiki software, if you haven't used that before. I tried to do the same thing 2 different times. So instead of changing any code, I just used it for 5 minutes, loaded up some Confluence pages, got a report, and then did the same thing and read through the same pages. And then I compared the reports. Let me see. There it goes. Okay. So here, okay, I loaded in 2 files. So you get both of the file information here at the top. The first one, they're not exactly the same at time. One was 6 minutes and one was 4 minutes. But there's this comparison tab where it shows you a comparison of a couple of selected stats. So this here shows the Wi-Fi data usage. So you can see blue, you can't really see it, but blue is file 1 versus file 2. So this means that my first run used 4.2 times as much Wi-Fi as my second run. And when you think about it, that makes sense because our great Confluence app developers are caching Confluence pages. So since I was looking at the same pages on my second run, I wasn't hitting the network as often. So that's kind of a relative stat, but if you scroll down, there's a bunch of reports, but where's the one I'm looking for? Okay, data transfer here is showing that my first run used 250 megs per hour in 6 minutes. But then my second run, since most of it was cached pages, then it only used, well, that says the exact same thing. But you can see in the graph that it used way less. It's 82 versus 347. And that's 1,000 kilobytes per hour. So again, there's a lot of information that you can look at here. There's things that should be the same across both if you're running the same sort of tests. The screen on time should be about the same. Then there are, let's see, there's some good comparisons. So again, this is that Wi-Fi information. Okay, here it is. 340 megs per hour on file 1 and 80 megs per hour on file 2. And so it pulls in the information from both reports and then does some judgment comparisons to show you information, to show you what you think might, or what it thinks you might find interesting. There's a lot of information here. Wake locks, Wi-Fi. Okay. And then this is a summary of the information. So both of them were running on a Nexus 5. Again, if you're doing a sort of test, it's best to do it on the same device just so you're controlling a variable. This shows that we had 3% of battery drop over those 6 minutes. So if you normalize that, that's about 30% of my battery per hour that was dropping, because this is a Nexus 5, which has a terrible battery. That's using 3% in 6 minutes. But then you can compare that to the second run, which was about a 2% drop. But since it was over 4 minutes, it's relatively similar, but a little bit less, so just under 29%. So again, a lot of these stats are going to be things that make sense, but what you're looking for are things that jump out and don't look right, and then that can help that can help you figure out what it is you actually need to fix in your app. Okay, so if you guys want, you can try it for yourself right now. If you have a phone, you can plug it in, run one of these bug reports. And then if you have Battery Historian pulled down on your computer, then you can use it there, or you can go to bathist.ef.lc and upload your bug report there. Anyways. Cool, so hopefully everyone's had enough time to pull down a report and look at it if they wanted to. Anybody have any trouble with it or find anything interesting? Or saving it for later, maybe. Cool, okay, so let's talk about some things that we can do with, things that we can do to improve battery life. So instead of best practices, maybe first we can talk about worst practices, things that you should not do in your app. The first thing that you should not do is to schedule frequent periodic alarms when not absolutely necessary. So a lot of these things, basically, before you do anything that could use a lot of someone's battery, you have to ask yourself, is this critical? Is this important enough? And not just in the scope of your own app, but in the scope of, remember that screen that we looked at where your app exists amongst, tens or hundreds of other apps on that person's phone. So think about it like, let's see, yeah, so for periodic alarms, there are other tools, and we'll look at one of those in a minute, that can basically do the same thing, but in a more battery-friendly way. Another thing that you shouldn't do is to sync data too often. So if you're doing background syncing, maybe you want to prefetch data so whenever someone opens up your app, they don't have to hit the network. But your app, your social network for cats app, probably doesn't need to download new feed information every 10 minutes just so they have the very latest up-to-date information. You want to kind of space that out, and even if possible, give the user an option to control that themselves. Like most Twitter clients will give you an option to sync every 30 minutes or hour or 4 hours or something like that in the background. So giving that control to the user where they can make the determination as to how much of their battery they want to give your app, essentially, is something that's a little better to do there. So another worst practice is not caching data. In that previous sample, in that previous slide where I was using Confluence, we saw that using that cache data can reduce the battery life, or reduce the battery usage, I guess. If you're just making network requests every time that you open the app for things that you just fetched, then that's inefficient. You're wasting battery life. You're wasting network data. You don't have to go and build out a sophisticated object-related caching system where you're taking in network responses and converting everything to local data models and then caching that in Realm or something like that. You can, and that certainly makes things a little better, but you don't have to invest that much time into it. At the very least, you can just cache the raw network requests. And if you're using something like Retrofit, then it's pretty easy to do that without having to write a lot of code yourself. So that's kind of an easy win if you do that. Then the last thing is abusing wake locks. So just like with the other things, anything that can impact someone's battery life, just think about it intently. Make sure that you are being a champion for your users and for their phones, treating their battery life as you would want your battery life to be treated. I guess maybe that's the golden rule of battery performance, is If you need a wake clock, if you need to force the screen to be active and it makes sense for your app, then certainly go ahead and implement it. But just make sure that you're doing it for a good reason, and where possible, give people the option to turn it off. I was working for a company where we were developing an exercise app, so you could track a workout, and on the workout tracking screen, whenever you're in the workout, it would show your pace information and other information that's relevant to the workout at the time. So we had an option to keep the screen on during your entire workout. So that made sense, but we also made it an option. If people are running and their phone's in their pocket, they don't need their screen on all the time. So we didn't just force it on during the workout. We let people control that themselves. So talked about worst practices. How about some best practices? The first thing that we can talk about is JobScheduler. So remember from before, your app is one of many on someone's phone. What JobScheduler does is it lets you take basically, I guess for lack of a better word, jobs, tasks in your app, and it lets you batch them and defer them and run them at a later time that might be better for the phone. So if you are doing some background syncing, maybe every 4 hours, if you're writing a Twitter client, every 4 hours you want to go and pull down new tweets. You could schedule a task yourself for your app to wake up exactly every 4 hours and pull in that information. But if you use JobScheduler to schedule that task, then the Android system will take that task and it will schedule it at a fuzzy 4 hours. So you don't get the actual 4 hours, but it'll group your tasks with other tasks on the phone at a time that makes sense. Turning on and off the network radios is a source of a lot of battery drain. So if you can combine your background processes with other apps' background processes, only turn on the radio once and then your code runs and their code runs, then that's going to improve battery life across the entire phone. So JobScheduler, like I said, it lets you take a task and defer it to run later whenever certain conditions are met. There's a couple of different conditions you can specify. You can specify the network type that's required, whether you don't need network, maybe you are running some sort of local analysis on pictures, you don't need network for that. Or if you're caching data, maybe you're caching a lot of data, you're prefetching a lot of data, you want to only do that when someone's on Wi-Fi versus if they're on a cell network. So that would be the unmetered network type, is if they're on Wi-Fi. You can also specify whether the job requires the phone to be plugged in. So if you're doing a very long running task, maybe you only want to do that at night when the user has their phone plugged in, you're doing some like photo backup or something like that. You can also specify if you want your job to require the device to be idle. So if you're doing something that takes a lot of CPU time, maybe you don't want to do that when someone is trying to use their phone, you want to do that at a later time. But remember, if you are setting these conditions for your job, that can delay the actual execution of it. If you're waiting for them to be on Wi-Fi and charging and idle, if you want to defer a task until that point, you might expect it to run in an hour, but it might not run for days or something. Jobs that you define can also have different properties. One property you can set is that the job should be periodic. So that means that your job will run repeatedly at a certain period. So it might be hourly, it might be daily or weekly. But remember, this period is kind of a fuzzy time period. Because JobScheduler does the scheduling for you. You might request that it run once an hour, and it might run at 12:30, but then maybe the next time it runs at 1:45, and then it runs at 2:25. So if you're doing something that needs exact timing, JobScheduler might not be the best thing, but if you can live with some flexibility in that time, then using JobScheduler will be better. Another property that you can set is persistence. So when you schedule a job, you're deferring a task for a later period of time. If you set it to be persistent, then that job will persist until it's run, even across restarting your phone. If you don't do that, then if the user turns their phone off, then that job just dies and it won't come back. If you set it to be persistent, then it will last until it gets a chance to run. So maybe you have a job set that will run whenever the device is charging, but someone uses their phone up until it dies, then they plug it in and turn it back on. If you've set it to be persistent, then that job will reload from the disk and then it will run because it's charging. But if you don't, then it'll just go away. You do need another permission for that. You have to set the receive boot completed permission, and then you can find out whenever the phone, or then the system will be able to start your job whenever the phone restarts. The last property here that you can set, there's other properties and other conditions. These are just some of the most popular ones. But the last one that I wanted to talk about was the override deadline. So you can set a deadline for your job to run, and that means that your job will run by this deadline whether or not the conditions have been met. So maybe you want to schedule a job for when the user has their phone plugged in, but you shouldn't wait longer than 4 hours for that job to run. So if by 4 hours the phone hasn't been plugged in, then the job will just run anyways. And that deadline is only valid for one-off jobs, not periodic jobs. So it's only for if you're deferring one task in the future. So this is what the code looks like. It's pretty simple. JobScheduler is a service that you can get from the context. So you just get that JobScheduler object. And then what you specify is the name of the service that will run whenever JobScheduler decides that your job is ready to run. We'll look at the code for the service in a minute, but for now we just define this component name that takes in the name of the class. So this is this should be my job service. This is a service that I've written that will run whenever the conditions are met for my job. And then job info lets you specify those conditions and properties that we just talked about. So here I've set the job to be periodic, that I want to run every 12 hours. I want it to run whenever the user is on Wi-Fi and if they are charging. So this would be something for like a background task or like a download task or something like that. When you're creating that builder object, you give it two pieces of information. The second one is the component name, but the first one is the job ID. And that job ID should be unique to your app, and it should be persistent across app updates. So you shouldn't use like a resource ID, something that could change whenever you compile your code. You can just define a constant integer, and then that ID can be used to reference your job later on. So in this case, since it's a periodic job, I'm scheduling it, and then it's going to run every 12 hours repeatedly. So I want to keep hold of that ID in case later on I want to cancel that job or modify it somehow. So here I just defined it as some random number. But yes?
So this every 12 hours.
Mm-hmm.
So what happens if you're not charging when it gets to 12 hours?
It will, if you're not charging at 12 hours, it won't run until you are actually charging. And then the task will run, and then I'm not sure. I would assume what it would do is then wait another 12 hours after that. It's not going to be, every day at noon and midnight it's going to check, and if you miss your window, you have to wait until the next one. It should, because the period is kind of fuzzy, it should push until the other conditions are met. So that's how you schedule your job. Whenever your job runs, it is going to start the service that you specified. So to write that code, you have to create a service that extends job service. And then there are two methods that you override. The first one is onStartJob. So that will get called whenever your job starts, obviously. You get an object called job parameters that gives you the job ID. So you could have one job service for multiple jobs in your app and then switch on that job ID. So you can do whatever it is you need to do. And then onStartJob is actually run on the main thread of your application, so you don't want to do your long-running work directly inside of the service. You need to start some sort of a background thread with an async task or another service or something like that, an intent service, I guess. And then inside of that code, once you are done with your job, then you have to call this job finished method with those same job parameters that you just got. So when you call job finished, that's telling JobScheduler that this job that you told me to start is done, and so you don't need to worry about it anymore. The second method on stopJob, that will be called if the job scheduler has determined that your job needs to stop before you've called job finished. So if onStopJob is called, then that means you need to cancel whatever sort of process is running. So that could be, the reason that that would run is maybe if the conditions have changed. So maybe your job is supposed to start whenever the device is charging, but then the user unplugs their phone quickly. Then onStopJob will be called so that you don't then run the rest of your job while the phone is unplugged. Do you get a context?
Yeah, the context, what context?
Context like Android context or context like
No,
Android context? So since this is a service, the service is a context, so you can use that. Mm-hmm. Yep, so yeah, you could post up a notification, you could do whatever you need to do with that context. Okay, so if we go back to the battery historian chart here, one thing I didn't mention is that there is actually a section here for Job Scheduler. So if we zoom in on that a little bit, we can see that Job Scheduler is running relatively periodically, but it's not at a consistent, every 10 minutes or anything like that. There are some gaps in between. But so if you set up Job Scheduler, if you set up your code to run some jobs, then you can run a battery historian report and make sure that those jobs are being executed when you expect them to be. So Job Scheduler is great. It's a platform API that was introduced in Lollipop. So that means that all the code that we just looked at would only run on Lollipop and later. So until this next thing I'm about to talk about, that would mean that for all of your users that are using KitKat or Jelly Bean or something like that, you'd have to have some other sort of solution to run these jobs. But the Firebase team has written a library that handles that for us. So instead of using JobScheduler, you can use this Firebase Job Dispatcher instead. If you go to that GitHub link there, then you can see how to add it to your project. But basically, it does the exact same thing as JobScheduler, except it supports back to Gingerbread. The library will actually use JobScheduler under the hood for Lollipop and later, so it's just like using JobScheduler on those OSs. But for earlier OSs, it uses some Google Play Services magic to schedule the jobs and basically replicate that platform scheduler operation on KitKat, Jelly Bean, ice cream sandwich, that sort of thing. So the concepts are all the same. All of the conditions and properties are all the same, but you just have to use a different library instead. Okay, so the last thing that I want to talk about is Doze. Doze is something that's been added recently to Android. Have you guys heard of Doze before? So it's a power-saving feature that was introduced in Marshmallow, and it uses phone sensors to determine if the phone has been idle for a while. And if it has determined that it's been idle, then it defers background processes to conserve battery life. So that means if you have a tablet running Marshmallow and it's sitting on your nightstand for an entire day, you're going to come back to it and it's only going to have dropped 1 or 2% instead of drained the entire battery throughout the day. So it's really nice for that sort of situation, but as developers, we have to be aware of it and make sure that our background tasks can run in these sort of maintenance windows. So this diagram just kind of shows how it works. Every orange line here is some sort of task, and you can see here at the beginning there's gaps in between, so we're running a download, doing something. Then at this line, the user has set their phone down and turned the screen off, so it's not moving. We're unplugged and the screen is off, but all these tasks are still running. And then after some indeterminate amount of time, Doze kicks in and defers all those tasks. So then Doze will schedule these maintenance windows where all of those tasks that would have run here now run just in this maintenance window. Again, that conserves battery life because you're only turning the wireless radio on, for example, that time instead of turning it on over and over and over. And then those maintenance windows come up periodically after that. There's not like a hard and fast rule where they run every 10 minutes or 15 minutes. It's just probably when there's enough things to run in a certain amount of time. So you can also see how Doze works inside of the battery historian report. Just above the job scheduler line is a Doze line. So you can see the orange bars here. There's some orange and blue. These bars are when the phone is in Doze mode. The reason that there are two different colors is because actually in Nougat they refined Doze to be a little more aggressive. I guess it's aggressive, but the aggressive mode is a little more forgiving. So instead of having to wait for your phone to be set down with the screen turned off and not plugged in, it can tell, or it tries to guess when the phone might be like in your pocket versus up and ready to use. So the orange bars here are when Doze is in light mode, and in those cases, you can see that the jobs and job scheduler are still running. They're just running a little less frequently. But then the blue is when it's in that deep Doze, when the phone has been set down or when it's idle for longer. So you can see here that there aren't any jobs that are running when it's in deep Doze mode, but then whenever I've picked the phone up, there's those green bars right after that showing that there are a bunch of jobs that were deferred that are all running now that I'm out of Doze mode. So if you're using Marshmallow or Nougat, something that I've noticed is you can pick up your phone and it's kind of sluggish at first as there are more notifications coming in and all those, basically those background jobs that were deferred, now those are all running. So it's almost like you pick up your phone and need to kind of give it a break to let it catch up with everything it missed before you can actually start using it. So what can we do with Doze? A couple different things. If you use Job Scheduler, you don't have to worry too much about Doze because we know those jobs are deferred for you. But if you can't or you don't want to use Job Scheduler, there are some other things to be aware of. In Marshmallow, Google added a couple of methods to Alarm Manager that allow you to schedule alarms that aren't affected by Doze at all. But remember, when we were talking about worst practices, you really want to use that only if you're absolutely certain that you need to run something every 10 minutes, something critical. Something else Google recommends is to use GCM. GCM, or Google Cloud Messaging, is one of the only ways that your app can run while in Doze mode. Google has it set up where they've basically just set up one single persistent connection to the cloud that can be used by multiple apps. So you can kind of think of it as like one little tunnel where your app can get notified and then other apps can get notified. So by just maintaining that one connection, it reduces battery, or it improves battery efficiency for the whole phone. So if you're building like a real-time messaging system, you could use that GCM connection to send a message to your app to wake up and pull down the full message, and that will run even when the phone is in Doze mode. Another thing you can do is you can force Doze mode to enable, so you can test to see how your app would actually run if it entered Doze mode. So instead of having to set your phone down and wait and hope that it entered Doze mode and then pick it back up, you can run this ADB command, dump sys device idle force idle, to force it to go into Doze mode. So what Google recommends is you can start your app and use it for a little bit, and then plug it in, run this ADB command, and then open your phone back up, which will exit Doze mode and make sure that nothing is broken in your app. That if entering Doze mode, like kills some service that you're using, you'd want to make sure that your app can recover from that service termination or anything else that would happen whenever Doze is fired. And so kind of a last resort you can do is to ask users to whitelist your app. So there are controls for you to say, hey, users, please go into system settings and specify that my app should be whitelisted from Doze mode so that it can run all the time. But for that, you want to really provide some value add to your users. You don't want to just request that just to get around Doze mode. And actually, that's in the Google Play guidelines, is that if there are only very certain conditions that you have to meet to be able to whitelist your app. There's a chart on the developer docs page that lists that specifically, but one of them is like if your app's core function is around scheduling automated tasks that have to run at a specific time, then you can request to be whitelisted. Or if your app is the way that some peripheral has to have some continuous connection to the internet, then you can request that a user whitelist your app. But the whitelist is user controlled. You have to request, you have to pop up something for the user to actually go into system settings and change it themselves. And then they can change it back whenever they want to. You're not guaranteed to even ever have that. So that should definitely just be a last resort for some very edge cases. Okay, so that is Doze, and that is all that I have. So hopefully you guys learned something about Battery Historian, hopefully got some information on what to do and what not to do, and hopefully you're doing some of these things already, so you don't have to go and clean up your app. But if you don't, then hopefully there's some things that you can go do back at work next week.